Residual is a type of what?
It's a number.
It could be a number, yeah, definitely. A residual is a type of error. Error. Okay? So that's definitely a question you might come across. It's also in your notes, so if you looked in your notes. All right, so we have this equation. We have this point on the scatter plot of negative 2, 4. Calculate the residual for this point. So I should have shown you this better yesterday, and I apologize again. My teaching skills are diminishing as I get older. Or maybe they're getting better, I don't know. All right. So the first thing I want to do is I just want to graph the line. Now, again, friends, do you have to graph y hat? Or just graph y?
Just y.
Just y. And the reason I'm going to go y equals is because I don't have to do y tilde because I'm not finding the line of best fit. The tilde on Desmos is what tells tilde to find the line of best fit. So I'm going to go y equals, and it looks like, is that 4.15? And then plus 0.65 plus 0.65x. All right. So let's make this, oh, that's 0.65, not 65. All right. So there is the line. This is our line that we use to make predictions. Does that make sense if I say that?
Yeah.
Okay. Now, we also have the point 2, negative 4. So what you want to do is you want to put 2, negative 2, 4 in on a table. So negative 2 and 4. Okay? So the nice thing about this is we could see possibly that is pretty close to positive 1. It's positive because it's above the line of best fit as far as the residual goes. If it was down here, it would be negative. But this is, does everyone agree that this probably is not exactly at negative 2, 3?
Mm-hmm.
So let's figure out what this is going to take place. So I'm going to, well, hello. So let's take a look. And it'd be awesome if you had like this written down in here so you can kind of comprehend what's taking place. Now, I really want to try and figure out what this exact y value is. This exact y value is 4 based on our point. But I want to find this exact y value right here to get my prediction. Okay? So what I need to do is I need to look at my point, and I need to look at the x value of my point. So if I have x equals negative 2, it's going to create us a vertical line there. So let's do that green or purple. Okay. So here's the nice thing. Is this purple line drawn? Is it part of the problem?
No.
Or am I using Desmos as a tool so I can figure out the intersection to get that y value?
Yeah.
Yeah, I'm using that purple line. It's not part of the problem itself, but I'm using that purple line in order to find this. Okay, so if you click here, you're going to see, okay, the y value at the intersection of the vertical line and our prediction line is negative 2, 2.85. Okay, so our residual is going to be this. So if you look back in your notes for it, the residual says it's the observed y minus the predicted y. So the observed y is this point here, negative 2, 4. The predicted y is that one that actually falls exactly on the line. Okay? So if I go observed y minus predicted y, observed y 4 minus predicted y, 2.85, 4 minus 2.85. So if you can't do basic arithmetic in your head like me, that's okay. 4 minus, what did we say it was, 2.85? So we have a residual, meaning the distance from our red line, our predicted line, that distance right there is 1.15. It's positive. Positive because it's above the line. It'd be negative if it's below. But truly make sure that you have this highlighted, this equation highlighted, because a lot of times I flip-flop in my head. Maybe it's because I didn't wear a helmet when I skateboarded as a kid. I don't know. So that's basically how I'd go through that problem. Does that make sense, my friends? Okay. So then it says if the point on the scatter plot for this regression model was 0, 3.8, calculate the value for the residual for this point. Show your calculation. Okay, so they're saying that you had a point at 0, 3.8, which is here. Or 1, 2, 3, like here. So being where my finger is, would this be a positive or negative residual? Negative. It's below the line. Does that make sense? Use that terminology? Okay, so I can go and plug that value in, or I could say, you know what? They told me that I have a new point. I have a new point at 0, 3.8. Okay, so that's below the line. And then if I wanted to, I could say, well, how about if I do x equals 0 as well? So, again, what was our equation? What was our equation to get a negative value?
Was it r equals y minus y hat or something like that?
We've got to go back to it. Let's make sure we remember it, because, again, I can't remember these things because I am dumb. And I'm kind of being playful on that, but I'm also kind of being serious and just allowing you to say, okay, I can realize, well, I'll do it. Observed y. Okay? The observed y minus the predicted. Where did the predicted come from? The line of best, or the actual red line, or did it come from the point itself?
The line.
The line. Okay. So they tell us that exists. We see the intersections here. So that tells us that if I use our information, observed minus predicted, observed minus predicted. Observed predicted, wow. All right. Observed minus predicted. So it says that we have this 3.8. So observed minus predicted. So I have, what did they say that point was? That was observed minus predicted. Observed minus predicted. Predicted was here. Right? That's my predicted. 4.15. Oops, I messed that up. 4.15. Okay, so 3.8 minus 4.15 is negative 0.35. Does it make sense that this is a negative point? Negative residual. And again, I'm using Desmos to do a lot of the work for us. Okay, you know, why not use the technology to allow us to think even bigger? I know, I've heard, oh my gosh, it's disgusting the literature that's coming out about education and technology. Guys, you got to realize the technology when I was born was such cruddy technology, and we still landed people on the moon. we used that technology. Yeah, we did have some people, we had mathematicians, these actuarial scientists that were doing the math to figure out the gravitational forces of the Earth and the moon and how to put someone to the moon, how to land them on the moon, how to do it safely and quickly. And that was the technology of the 1970s, 1960s, and 70s. Okay? What will the technology today being used as a tool allow your generation to come up with? Like, who knows? So I love the fact that we can utilize the technology to allow us to think even further than where we've been. I mean, it's very possible your guys' generation is a generation that figures out how to cure cancer. Why is that? Well, you were able to utilize technology to allow your thought process to take you further because the technology took you to a point and then you went beyond what the technology did. That's cool. And I am fully embrace that. And I tell you what, I sit there, I argue for your guys' generation all the time. You know, I was just down in Arizona. I had buddies like, oh man, the kids these days. I'm like, dude, kids these days are a hell of a lot smarter than we were. Shoot, we used to go play in graveyards and crap like that. So that was a Halloween story for those of you who missed it. All right, number 3. It says, if a point on a scatter plot has an x value of 4 and a residual of 1.2, find the associated y value. Okay, so if I have an x value of 4 and a residual of 1.2, find the y value. Find it. So I have an x value of 4. X value of 4. If I come up here and it says I have a residual of positive 1.2, well, I have to figure out what this point is, and it's positive 1.2, so the residual is above this. So we want to figure out what this data point that would be 1.2 above this line would be. So again, let's use the technology to think deeper. Okay, so we're saying that I had an x value of 4. Okay, and then we had a residual of 1.2. Okay, so all I have to do is I have to find this point. That's 6.75. Okay, so 6.75. And I have a residual of what? 1.2. So 1.2 plus 6.75. So this would give me a data point, an observed data point up here at 4 comma 6.75. 6.75, somewhere in here. Or 7.95. So 6.75 is here, residual of 1.2 above it means that 7.95 up here is where this data point would have existed. So I kind of reverse engineer it.
Where'd you get the 6.75 from?
Oh, okay. So I found this right here.
Why?
That 6.75 was the predicted. Right. I have a residual that's positive, so it's above it of 1.2. So I had 1.2 to 6.75. 1.2 plus 6.7, so 7.95. It means I would have a data point up here at 4 comma 7.95. Huh. Friends, are we okay up to these 3 problems? Anyone have to clarify any further? All right. So then we're going to move down a little bit. It says a major psychological study was performed regarding whether career satisfaction is associated with longevity. Use a partial data set to illustrate the concept. So job satisfaction score was all of those. Years survived was those years. Create a linear regression, calculate the residual. Okay, finally. Now I can finally do the residual on Desmos. So let's get rid of these things. I need to create a table. Okay. So my first data point, I believe, is 8 and then 75. Will someone tell me what the next data point would be?
776.
7 and then 76.
470.
4 and 70.
564.
5 and 64.
266.
2 and 66.
885.
8 and 85.
676.
6 and 76.
470.
4 and 70.
789.
7 and what?
89.
89. That's it. Cool. So we don't see our data yet. Well, hit the plus. There's our data. Okay. Just by looking at that right there, I can tell you things about our correlation real quick. It's positive correlation, and I'd say it's moderate to weak. Okay, our line of best fit is going to somehow figure out in there, and we talked about yesterday what Desmos will do, or whatever program you're using, is going to use to make the least squares regression. Meaning it's going to create a line of best fit. It's going to make a whole bunch of squares, the shape of the square, on how high and how low, below, above and below our line would be, and it's going to figure out the smallest summed up value of the area of all those squares. And that's how Desmos is going to make a line of best fit using the sum squares. Now we can't make the sum squares on Desmos, but what we can do is we can make our line of best fit. So why am I going to use equal or am I going to use tilde? Am I going to use equal or tilde to find the line of best fit?
Isn't it tilde?
Tilde. Yeah, tilde. That little tilde is going to say, oh, okay, Desmos, we need to do this. And then we're going to go, oh, and I have to make it y1. Sorry about that. y1 tilde mx1 plus b. And then all of a sudden, they perform this thing. Now they have the r squared value, and then they have the r value. The r value is 0.73. So that's probably a moderate. Like I didn't know if it was going to be weak or moderate, but 73%, you did moderately well on a test. So you got a 73. Okay. But that's our line of best fit. So create the linear regression model for this data, show the meaning of each variable. Okay, so my equation is y equals 2.96x plus 57.7. Okay, so you're plugging your m value in here, you're plugging that, and you're going to go to y equals. Okay, that's going to give us that. So create your linear, show the meaning of each variable. So the slope is the change in the y direction or the change in x. Well, the y direction is years survived. Okay, so our slope in the context of this problem is you're going to live 2.96 more years for each satisfaction rating 1 higher. Okay, so you're going to live 2.96 years longer for each time that our x value, our job satisfaction, goes up by 1. Okay, is that true? I don't know. I gotta tell you, and I've told you all this before, I don't work. Like people are like, dude, when are you retiring, Stirrup? I've been retired for 29 years. I just show up to a school, teach. This isn't work. Okay? So the next thing it says, calculate the residual for a subject that survived 89 years. Now here's the problem. Here's the problem. If I look at this 89 here, I also have 89 in my data set. And a lot of students would say, oh, that has to be 7 because that was that. No. At 89 years, like here, if I bring this over and fall somewhere on here, that's going to give me a predicted value. There is a residual that's going to take place. The point 7, 89, 7, 89 is right here. Okay, so if we said create a residual for a subject that survived 89 years, where's the 89? 89's here. Yikes. Like that's a big old positive residual there. Do you agree? All right. So, really bad math if you make a prediction based on the y-axis. It's always coming off the x-axis. So, I can't use the 89 up here on our screen, come over and then come down. Okay, that's really bad. But because I have a data point that's at 7,89, what I can do is say, okay, I can go ahead and create myself another line. So I'm going to go x equals, and because my data had 7,89, I'm going to go x equals 7. So I get that. So this is going to give me that. And I know that this point up here is 789. Okay, so observed is from our data. That's 89. Expected, where do these guys intersect? 78.5. So 78.5. So we have a residual of 10.5, meaning the distance from this green line up to this data point is going to give me 10.5, positive direction. If it was below, it would be negative. Okay? So that's the information we have so far. Show your calculation. Well, there's no reason to show it when you use decimals to figure that out. Okay? 10.5, you just put 10.5 for an answer, you get all day long. Explain the meaning of the residual in the context of this problem. Okay, so this right here was at the point 78.5. This data point did this. So our prediction under-predicted what our data point showed. Okay, our data point showed right up here. We under-predicted, so it's like, wow, it was just good. Was it by mere chance I was over? But I under-predict here because this green line is what I'm making predictions off of. I under-predicted based on that one single data point. Okay? So is it okay to under-predict? Sure, it's all the context. Calculate the residual. That person had a job satisfaction of 6. Job satisfaction of 6 is here. 676 came from our data. So now I want to figure out the 6. So what should I do on decimals? What should I change this to? What should I change that to? Row. So we're on problem number 7. Should I keep it at the 7 like it was?
No.
Change it to the 6, right? Cool. So I have that right there is my predicted, but my data at 6 showed 76. So observed minus predicted. So my observed was 76. Yeah, it's very close to 0.5. So my observed was 76. My predicted was where these two crossed each other, 75.54. Oops, I did it again. 75.54, go down here. 75.54. So 0.46. It's barely above. It's positive because it's above our line of best fit, which is good. Okay, explain what the meaning of the residual in the context of this question is. Our prediction, we under-predicted because, again, my data point was above it. So I over-predicted by a little bit, by just 0.46. But, you know, life happens. All right, calculate the residual. Subject that, job side, we did that. Explain the meaning, we got that. All right. Number 9, if you live longer than this regression model predicts, you live longer than this predicts, is that a positive or negative residual? If you live longer, that's vertically. So if you live longer, am I going to answer this right? It would be positive because that would be your predictions on the green. You live longer, so you are above it. So that's a positive residual. Okay, it's above our predicted line. Now, one thing I wanted to show you that also takes place, let me get rid of a couple of things here. Let me get rid of these two things. And I'm going to move this up a smidge. I want to get down to here. So if you hit your residuals here, those data points for the residuals, let's make those blue dots. Okay. All right. So take a look at those blue dots down here. These are the vertical distances above or below our line of best fit. If you look here, if you look at those residuals, if there is not a pattern on the residuals, this is another key indicator that things are good. If those residuals created some sort of pattern where it looked like a parabola, or it was like, oh, there's, this data here, residual patterns, if it did like a fan out type of thing or anything like that, that means that we don't have a good model any longer. Again, these are things that you can use as you go through your adventures of statistics to help you know if something's good or bad. You could have a really good line of best fit. You have a correlation that's incredible. And if you look at the residuals and there's a pattern on the residuals and it's not just a random scattering of points, that random scattering points is definitely what you want. If you had a parabola or you had some other shape, or if you had it like it fans out or anything where you look at those blue dots. Now, I want to make sure you understand what those blue dots mean in reference to our red dots. Those blue dots, you see all of these, we have our data points and we have negative 6.46. This means at the point 8, at 8, this has a negative distance right there. It's underneath. That means that this distance, that vertical distance, this is a way of looking at, do I have a pattern taking place with this? Sometimes when you have a line of best fit, you don't see a pattern. But if you take the residual saying, how far above and how far below, distance-wise, would I be? If it's positive, it's above. If it's negative, it's below. I just plot with those residuals look down here. And again, I don't have really a pattern here. Now, there's not a whole lot of data points to look at to see a pattern. But if you got this down here, where all of these is like all over here, and then under here, and then over here, like kind of looks like a parabola, or all underneath, all above, and all underneath, like an upside down parabola. A parabola is just one idea about it. But if the residual itself has a pattern, that becomes something that you can start saying, we need to go find a different way of collecting data on this. We're not showing correlation. Yeah. Go ahead. So residuals are a very powerful thing that very few people actually comprehend. But it becomes something that if you are a boss of a company and somebody comes to you saying, I've got a problem here. We looked at all of our data. We plotted our line of best fit. Leroy over there, he's starting to make predictions. And you have the smart math person, and you're smart as well, that's saying, hey, look, our residuals show a pattern. You might want to bring old Leroy in and say, look, our residuals show a pattern. You're making predictions. You're spending our money. And because this residual had a pattern, that's bad news. Okay? It means a lot. But this is like the afterthought. It's like no one wants to look at this. They want to look at this and say, oh, look at how wonderful this fits. Look, we have this R value. Yeah, it's moderate, but hey, it's good. We like it. No, take a look here. I mean, this right here reinforces even more than this 0.73. Because I don't have a pattern, this means it's 0.73. We can continue to collect more and more data based on this. We just go out to 10,000 employees and say, you have this job satisfaction of 1 to 10. or 0 to 10, and you track how long they live, there might be really something to this, even though we have dots that created this to give us a R value of 0.73. Okay, this not showing a pattern is big news. Hint, hint. Okay, if you show a pattern, and it's not a random scattering of points, that means you need to go look for other things that you're going to compare this to that. Okay, don't trust it. And again, the residuals are important. If you can see the residual plot, it's important because you can definitely see a pattern based on that. All right, I'm only on the 2.7. Oh, I want to show. I know I didn't assign you this. This here on 2-8, which is not an assignment I gave you yet. This is the residual. That's those blue dots. Do you see how it looks like a parabola on here? That means right away, boom, throw it away. We're not going with it. It's another piece of evidence for you. I know I didn't teach that yet, but I'm just showing you just how to show up. All right. As we come down a little further. Okay, so studies have been done whether extroverted people make better salespeople. In psychology, extroversion is a person who is energized by interaction with people. Let's assume that 500 different salesmen have been studies for both personality and ability to sell products. Each salesperson is given a score for extroversion from 1 to 100 and sales ability from 1 to 100. Okay, they come up with this equation, 56.65 minus 0.02543 x, basically, with an R value of 0.08. Is this R value good? 0.08. This is like earning 8% on a test. That's your first clue that this is a really crappy comparison. So you start seeing R values this low, that R value is getting really close to 0. This is not good. Shame on this company for acting like we're going to do it. It says James, the salesman, is given an extroversion score of 70 and a sales score of 55. What is his residual? So what we have to do with this is we actually have to just use our calculator to start dealing with it. Okay? So I'm going to get rid of all of this stuff. I'm just using it as a calculator. Okay, so I'm going to go. I'm going to get close to this because I can't see it. I have 56.65783 minus 0.02543.6. And they said he was given an extroversion score of 70. So I'm going to go times 70. Okay, so the predicted score for him was a 54.87, 54.88 if we rounded to 2 decimals. They said he was given a score of 70, but the predicted score for this person would have been a 54.87. Okay, what is his residual? Okay, so 70 is definitely above our line. So his observed score was a 70. We're going to subtract that from the 54.88, rounded to 2 places. So the line of best fit under-predicted what that salesman's score actually was. Okay, it's positive. That means it would have been above our line of best fit. We don't even have to graph it. We can just use the math to deal with it. And then it says, Emmanuel was a salesman who had a residual sales score of 16. Explain what this residual measures in the context of the question. Okay, so a positive 16, way above our line of best fit. That means that the prediction for Emmanuel was under predicting what he actually scored. Okay, because it's positive, it's above the line of best fit. If Emmanuel has an extroversion score of 40, calculate his sales score. Okay, so if he has an extroversion score of 40, if I plug 40 into this equation, I would get his sales score out of it. So I'm just going to change our 70 up there to a 40. So he is 55.64. And then, does extroversion appear to be a good predictor of sales ability? What evidence? Okay, did I plot data to get this line of best fit, or did they just give us the predicted line? Did I plot any data to get that? No. So the only thing, I don't know how much our residuals are going to take place, or it's a pattern or not. I don't have that. I have this as 0.0872. That is a very weak but positive correlation. Okay? 8% on a test, you're going to be pretty upset with yourself if you get 8% on a test. Okay? Don't be that kid getting the 8%. That means you barely spelled the name right. All right. So, number 11, no, because the only thing we have as an indicator if it's good or bad, R value. R value is a positive, but it is extremely weak. So that's very close to 0. So I wouldn't even pay attention to the study. I would just ignore it. And again, these are things that me as a person, anytime I go to any of the things saying, hey, we showed all this, look at our data, look at our data, look at our data. Oh, look at this line that trends with our data. What's your R value? Oh, we don't have an R value. Yeah, you do. What is it? I just did it here on my calculator. I just used decimals, got it. Oh, we don't look at that. Well, I'm ignoring everything you say now. I mean, I kid you not. You should see the people who teach statistics. Myself, Mr. Anderson, both Mr. Andersons, Mrs. Lewis, Ms. Quayle. I mean, it is eye-rolling material where they're sitting there, they're trying to push stuff on us. And it's like, you're not showing me anything. So, oh, no, the data says a lot. The data says shit. It doesn't say anything. You didn't create a line of best fit. You didn't have a predicted model or anything like that. All right. And then number 13, last one I can cover for today because we're almost out of here, right? Yeah. Okay. Stefan earned a residual score of 0. Explain why the z-score of 0 means in the context. Okay. So a residual of 0 means that their predicted value and their data point was exactly on the line of best fit. That's fine. That just means the residual was a perfect fit. It was a perfect match. Friends, I don't have any homework for you tonight. I'm sorry.
Yay.